In this video, I'm going to show you how to develop a Reaction Plan Manager++ solution to write data to data files. Now, why would I need to do that? Well, maybe you have DNC software that will upload adjustment values from a data file to a CNC machine. You need Reaction Plan Manager to write the data in a format which is acceptable to the DNC software. With Reaction Plan Manager, you can do such a thing. You can write data to data files with the adjustment values in them. In this video, I'm going to assume you already know how to develop a basic Reaction Plan Manager++ solution. If you're unfamiliar with some of these topics, watch some of the videos in the help library. Throughout this video, I'm going to use the RPM Training CMM simulator to generate measurement data. I also have the Microsoft Explorer open, pointing to a particular directory, so you can see data files appear in the directory, so you can get a feel for how the software works. And of course, this is Reaction Plan Manager++. I'm going to build a solution from scratch. I know that RPM++ write new solution. I know that solution does not exist within Reaction Plan Manager++. So I'm going to inspect a part using the Training CMM and let the Auto Solution Builder do its thing to build a basic solution. So I've done that, and here you can see I've got a bunch of dimension items waiting for me to actually start configuring accordingly. The first step in configuring a solution is to set up the data collector. So I'm going to go to the edit mode, pull up the data collector, and I'm going to set up a filter to filter on the machine. So if I slide over to column AA, there's where the data is for the machine. I'll go ahead and add that filter. Then I'll process the data so that I have a machine A reaction plan over here on the left. So I've created the filter, I've processed the data to give me a reaction plan for the machine A. Let's get rid of this starting reaction plan. And I don't really need to look at all these dimension items. Let's get rid of some of the dimension items to keep things simple. I'm going to keep holes 1 and 6 and get rid of the rest of the data. I picked holes 1 and 6 because I know the RPM Training CMM, I know the data reacts more rapidly for holes 1 and 6, and it'll go out of spec quicker than the other holes. While I'm thinking about it, let's go ahead and group some of this data as well. Now, usually you're going to group all the dimension items accordingly, but I'm only going to put the diameters into a group. So let's go to the dimension organizer, and I'm going to insert a new group and leave the rest of that the same. Let's change the group here so that it says something other than group 1 diameter. Let's change it so that it reads diameter. So I'll go to the quick group edit and change this to diameters. And let's go ahead and display a process reset. Oops. We are now ready to configure this solution to write data to data files. Data files are associated with specific reaction plans. In this example, we've got offline template and machine A. Offline and template are really used for developing solutions. The machine A is a reaction plan that can be configured to write data to data files. So if I click on machine A, I can configure this to write data to data files. If I had a machine B, it would have a different configuration. If I had machine C, it would be a different configuration. If you see the word advanced as a label for a tab or a menu item, that means the properties associated with that menu item or tab are specific to the selected reaction plan. Let me repeat that. If you see the word advanced anywhere in the software, the properties and settings associated with that tab or menu item are specific to the selected reaction plan. For example, I've got machine A selected. If I click on this dimension item, you'll see tabs that are labeled with the word advanced. Advanced message overrides and advanced output. If I make any changes to the properties in this tab, it will only affect machine A. If I click on offline reaction plan and click on the same dimension item, you'll notice the advanced tabs do not exist because the properties and settings are global. They'll affect all the reaction plans in this list if I make any changes to this, because I do not see the word advanced. So let's go back to machine A, and we can go ahead and configure this to write data to data files. I have to configure the output behavior. The output behavior determines when the data is written to a file. And I also have to tell it the name of the file. Once you've got that set, you can then configure each dimension item to write the contents of the file. So to set up the output behavior, I have to configure the properties and settings for the reaction plan. So if I click on the header of the reaction plan, it will bring up the appropriate menu items to change for the reaction plan. And you'll notice you have a tab here called Advanced Output. The Advanced Output tab are the properties and settings associated with writing data to a file. The output behavior is the first property in the Advanced Output tab. The output behavior determines when the data file is written. You have three choices here: no output, output when process reset button is pressed, and output when new data is received. I'm going to leave this set to output when process reset button is pressed. So you may have an output event and no data written to a file. It's dependent upon how you have your reaction plan configured, how you have the dimension items configured. Apply process reset on dimension items with rule violations. We'll talk about that later. The default output determines what data is written to the file by default if there is no dimension items that meet a particular severity level criteria. In other words, if none of the dimension items are going to write data to a data file, this could be the default data that's written to the data file. The output type, here's where you have to tell it if you want data to be written to a file. It needs to know that you are writing it to a file, so I'll check that. And you can append the date and time stamp to the file. I'm going to check that so that you can see when data file is written, you can see that date and time. Now clearly I have to put in the output file name here, so I'm just going to go over here and I'm going to copy the path from my Explorer here, and then I'm going to give it the name machine A as the default, and we're going to make it a CSV file. I'm going to save those changes, and then we can start working on the specific dimension items. If we did nothing right now and went to the view mode and started running this solution, if the operator pressed the reset button when a rule violation occurred, there would be no data file written because we didn't configure the dimension items to write data to data files. There's nothing to write, so therefore nothing would be written to the file. So what I want to do now is configure the dimension items so that when there is a percent of tolerance rule violation or an out of tolerance rule violation, it will write something to a data file. I don't really care about what's written to the file at this point in time. I just want you to understand when the file is created. So to do that, I'm going to use the quick dimension edit. I'm going to choose, or select I should say, I'm going to select all the dimension items, go to the Advanced Output tab, and I'm going to put some generic output when there's a rule violation for the percent of tolerance rule and the out of tolerance rule. We'll say something like percent of tol violation, adjust by, and then I'll put in the correction amount, last run correction, as a variable. We'll do the same thing for the out of tolerance, but we'll say out of tolerance. We'll apply those changes. Now we have something that will be written to the file if the percent of tolerance and out of tolerance rule violation occurs. Let's go to the view mode, save our solution, and measure some parts. Now we're going to run this until we actually get a process reset button appear. And we've got 3 dimension items that have triggered a rule violation. We've got a percent of tolerance rule violation. So when I press this button, it should generate a data file if I press any of these 3 buttons. Now the idea behind this is when you have this configured to press button if adjustment made, this gives the operator a chance to review the data and make a decision whether he wants to actually make the adjustment or not. So if he didn't want to make the adjustment, he would just measure some more parts. I'm going to press this button and watch what happens. An output event occurred. See the button up here which says output events? And you'll notice here a data file was created. If I click on the output event button here, it'll show me that I had a percent of tolerance rule violation, and I can expand this and you'll see that it was the Y dimension and the output was percent of tolerance violation adjust by minus 0.0051. So if I open up this file, I should see this data written to this file. So let's go ahead and open it. And it opened it up in Excel. And here you can see that it indeed wrote these contents. The contents of the file was indeed percent of tolerance violation adjust by minus 0.0051. I don't need to save that file, so you get the idea. If I click on another button, it will create another file. Now, if I didn't have the date and time stamp appended to this file name, it would just overwrite the file. Let's measure another part. This time, instead of filtering on machine A, let's filter on machine B. Same kind of thing. We have the process reset button is pressed, configured so it's turned on. If I press this button for the 1Y like I did in machine A, it'll generate an output event. However, you'll notice in the Explorer down here, it did not generate a file. That's because we did not configure machine B to write data to a file. If I open up the output events and I look at the 1Y, you'll notice that there is no output written to the file because it's just not configured to do that. Since the output behavior for machine A was set to when process reset button is pressed, the contents of the file was really dependent upon the dimension item. So when I pressed the 1Y process reset button, it only wrote data for this dimension item. If you're dealing with a group of dimension items, and I have the process reset button for the group, it'll look at all the dimension items in the group, and if any or all of the dimension items, the specific dimension items that violate the rule violation, will generate data to the data file. So for example, if 1 diameter and 6 diameter both had violated the rule violations, we would see two records in the file, one for the 1 diameter and one for the 6 diameter. If I have the output behavior set to output when new data is received, it behaves differently. It will look at all the dimension items when new data is received, and if any of the dimension items in the reaction plan violate the rule violation, which would be the percent of tolerance or out of tolerance rule violation in our case, it would generate the records for each one of those dimension items. This is really better suited for an automated type environment where you want to eliminate the operator from the adjustment process altogether and just let it happen when a rule violation occurs in the document or in the reaction plan. Let's edit the machine A reaction plan so the output behavior is output when new data is received. So I'll go to the edit mode. I'll click on the machine A reaction plan, click on the reaction plan header, and for the output behavior I'll change this setting to output when new data is received. Save the changes and then go to the view mode. Save that document. I'm going to hit the inspect button. New data is sent over to RPM. It's analyzed. Notice a new data file was written. If I open up that data file, let's see what was written. Let's see the contents of that file. Notice I've got 1, 2, 3, 4 different records for this file, which corresponds to the 1Y, the 1 true position, 6X, and the 6 true position. So the 4 different dimension items that that violated an out of tolerance rule violation, the data was written for each one of those dimension items. There was no button press. The data file was just written automatically after the analysis took place for machine A. So in theory, some other piece of software should have picked up this file and made adjustments to your process. And we could simulate that by clicking on the reset button here. So now if I inspect another part, it should go green. Notice there was no data file written, even though we measured another part. That's because there was no new data written. There was no contents to the file. If I click on the Output Events button, I can see that. So here is where we just measured a part. Everything is green, so there was nothing written to a file. And for this output event, this is where we actually did have stuff written to the file. So again, an output event occurred, however there was nothing written to a file, therefore there was no file written. In this automated environment where the operator input is eliminated, a process reset is required when an adjustment is made, so you don't mix before adjustment and after adjustment measurement data. To do that, you click on the Edit mode, go back to the Machine A reaction plan, and you'll notice there is a setting for Apply Process Reset on Dimension Items when Rule Violations. If I check that, save the changes, what will happen is if data is written to a file because of adjustments, it will apply a process reset to the group or the individual dimension item based upon the corrections that were made. Let's go back to the view mode and run some parts for Machine A and watch what happens. And we're going to have to run it a little bit to actually generate some rule violations. By the way, while we're running it, the output events are occurring and we're capturing those events. Notice this last part that we ran, we did incur output event, which a rule violation, which triggered a data file, and you'll notice those entries, there's 3 of them here, that performed a process reset. If I open up the output event log and look at the last output event, you can see that the 1 true position, 1 TP, output data, 6x output data, and the 6 true position or 6 TP, it also output data, which corresponds to my 3 process resets. You now understand how to configure a reaction plan to write data to a data file. You can configure it so that the operator evaluates the report and makes a decision whether he wants to make an adjustment, and he can press a button and that'll generate an output event. Or you can automate the whole process and eliminate the operator and just have it automatically write the data file and apply a process reset. There are additional dimension item properties that can influence the output behavior. For example, you have an automated environment and you know that you have 3 parts that are in the queue to be measured when RPM does an analysis, recommends an adjustment, and writes the file. After the file is written, you need to ignore the next 3 parts. So you can simulate that, or you can design your dimension item to behave that way. Another example may be after the adjustment is made, maybe you want to ignore the next X number of parts to take advantage of averaging. You can design your dimension item to do that. There are properties that will let you ignore rule violations before and after adjustments are made. let's design the machine A reaction plan so that the dimension items are configured to ignore 3 parts with regards to rule violations after a data file is written and before a process reset occurs, and we'll also configure it so that it ignores 4 parts after the process reset. We'll go to the edit mode, and then we'll go to the quick dimension edit. We'll choose all the dimension items. If you look under the process reset section, you'll notice number of parts to queue before applying process reset and number of parts before monitoring rule violations. So if I put the number 3 here, that'll simulate my 3-part queue before process reset. And if I put 4 here, it'll ignore the rule violations after the process reset. Let's also change our last run reaction so that we're going to average off of 4 parts. We'll apply those changes, say OK. Now go back to the view mode, and we can start measuring parts, but right away you can see from machine A the monitoring is off, waiting for minimum number of parts. So it's saying you've got 4 parts that we're waiting for before we actually turn the rule violation monitoring back on. And you'll notice is for all 3 of the dimension items, the 1 true position, the 6x, and the 6TP. Let's measure some more parts and see what happens. I'll inspect 1 part, another part, another part. Now what will happen is the monitoring turned on. It triggered a rule violation, and data was actually written to a file. Now we're waiting for 3 parts to purge before turning the monitoring back on. So if I look at the output events, you'll notice that we have an output event for the data that was written to the file. So now it's waiting for us to measure 3 more parts to simulate the queue. Let's measure some more parts. I measure 1 part, 2, and now 1 more part from our 3rd part, and it triggered a process reset, and now it's waiting for 4 parts until the monitoring is turned back on. So you see how that works. Using these dimension item property settings, you can configure your reaction plan to duplicate an automated environment. In this video, you learned how to configure a reaction plan to write data to a data file. You know how to set it up so that an operator can look at the report and make a decision whether he wants to make an adjustment or not, and press the process reset button to generate the file. You also learn how to set up an automated environment where data will flow into the reaction plan, do an analysis, and generate the data files automatically. To learn more about this topic and other Reaction Plan Manager++ topics, visit www.beckerqualitysolutions.com.